Hello, space enthusiasts, and welcome back to our channel. Today, we're diving deep into a story that's been making waves across the astronomical community and beyond. You've probably seen the headlines, the articles, the social media posts buzzing with excitement and maybe a little bit of confusion. We're talking about the interstellar visitor known as Comet 3IATLAS. It's a name you're going to want to remember. So, what's the big deal? In a nutshell, a comet from another star system is currently cruising through our own cosmic neighborhood, and it's acting well, a little strange. The media has been having a field day with this, and it's easy to get lost in the hype. That's why we're here today. We're going to cut through the noise, separate fact from fiction, and give you the real, scientifically grounded story of what makes 3IATLAS so incredibly fascinating. We'll explore where it came from, why it's behaving so unexpectedly, and what it could teach us about the universe beyond our own sun. So, buckle up as we embark on a journey to understand our newest interstellar guest. Let's start at the very beginning. The story of 3IATLAS began in July 2025, down in the high-altitude deserts of Chile. A powerful telescope system known as ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System, spotted something new. This wasn't just another rock floating around our sun. Its trajectory was different. After careful calculations of its path, astronomers confirmed its origin. It came from interstellar space. This makes it only the third such interstellar object ever detected, following Oumuamua in 2017 and Borisov in 2019. The 3I in its name literally means it's the third interstellar object. As you can imagine, this discovery sent a jolt of excitement through the scientific world. Telescopes across the globe, and even some in orbit, immediately turned their gaze towards this newcomer. Every observatory, from professional institutions to dedicated amateur astronomers, wanted a piece of the action. The race was on to gather as much data as possible before 3IATLAS swings back out of our solar system, destined to return to the void between stars. This data blitz led to a flurry of scientific papers, articles, and discussions. Everyone wanted to know, what is it made of, how big is it, and most importantly, what secrets does it hold about the star system it was born in, a place we can only dream of visiting. Now, this is where our story takes a truly unexpected turn. When astronomers first plotted the course for 3IATLAS, they also made predictions about how it would behave. Based on its size and distance, they estimated it would have a certain brightness, or magnitude. For those unfamiliar, in astronomy, a lower magnitude number means a brighter object. The initial prediction was that the comet would hover around a magnitude of 20.5, incredibly faint, visible only to powerful, professional-grade telescopes. This is standard procedure. We have models that are pretty good at forecasting how comets will brighten as they get closer to the sun. But 3IATLAS didn't read the script. It decided to put on a show. Instead of staying at its predicted faintness, the comet started getting brighter, and not just a little brighter. It surged to a magnitude of 19.28. Now, I know the difference between 20.5 and 19.28 might not sound like much, but in astronomical terms, it's a huge leap. This isn't like a light bulb getting slightly less dim. This is a significant, noticeable increase in luminosity. It defied all the initial models and expectations. It was as if a quiet guest had suddenly walked into the center of the room and started singing opera. This unexpected brightening was the first major clue that 3IATLAS was no ordinary interstellar comet. It was different, and astronomers everywhere were scrambling to figure out why. So, what caused this dramatic and unforeseen surge in brightness? Scientists got to work analyzing the light coming from the comet. What they discovered was astonishing. The flux, which is basically the total amount of light and energy being emitted by the comet, had increased by a factor of 5, a five-fold increase. That is a massive outburst for any comet, let alone one from another star system. This wasn't a gradual brightening. It was a sudden eruption of activity. What does this mean in practical terms? Comets are often called dirty snowballs. They are mixtures of ice, dust, and rock. As they approach a star, the heat causes the ices to sublimate, turning directly from a solid into a gas. This gas creates a glowing atmosphere around the comet's nucleus, called a coma, and a tail of gas and dust that streams away from it. A five-fold increase in flux suggests a huge, sudden release of gas and dust. It could have been a pocket of highly volatile ice that was suddenly exposed to sunlight, or perhaps a section of the comet's surface crumbled away, exposing fresh material underneath. Whatever the cause, this outburst was a dramatic event that caught everyone by surprise. It told us that the surface and composition of 3IATLAS might be far more dynamic and unstable than initially thought, adding another layer of mystery to our interstellar visitor. With all this strange behavior and the flood of information, it's no wonder the media and the public have been captivated. We've seen headlines ranging from sober scientific reporting to wild speculation. Is it an alien probe? Is it going to do something even crazier? This is where our mission today becomes so important, to clarify the facts and provide a deeper, more grounded understanding of what's really happening. Let's be clear, all available evidence points to 3I-ATLAS being a natural object, a comet. Its behavior, while unusual, is not outside the realm of what comets can do. Comets from our own solar system have been known to have outbursts, fragment, and change brightness unexpectedly. What makes 3I-ATLAS special is its asterisk origin. It's a sample from another solar system, delivered right to our doorstep. Think of it this way. Imagine you're a geologist who has only ever studied rocks from your own local area. Then one day, a package arrives containing a rock from a completely different continent. You would study that rock with incredible intensity. You'd analyze its composition, its structure, its age. Every little detail would give you clues about the geology of that distant land. That's exactly what astronomers are doing with 3IATLAS. The light from the comet is being passed through spectrographs, which break it down into its constituent colors. This tells us what chemicals are present in its coma, revealing the building blocks of the planetary system it came from. Are the ratios of certain elements the same as in our solar system, or are they different? The answers to these questions could either reinforce our theories about how planetary systems form, or force us to rewrite the textbooks. Furthermore, studying its physical behavior, like the dramatic brightening event, gives us insights into its structure. Is it more fragile than the comets in our own Oort cloud? Does it contain different types of ices that we're not used to seeing? This unexpected behavior isn't a sign of something unnatural. It's a scientific puzzle, and a thrilling one at that. It's a chance to learn something new, to test our assumptions, and to expand our knowledge of the cosmic neighborhood. This comet is a messenger from a distant, unknown star, and astronomers are working tirelessly to decipher its message. So what's next for 3IATLAS? Its journey through our solar system is far from over. It will continue to be monitored by a global network of telescopes as it makes its closest approach to the Sun, a point called perihelion. This is when the comet will be at its most active, heated most intensely by our star. Will it have another outburst? Will it fragment into smaller pieces, as some comets do? Or will it survive its solar encounter intact and begin its long, slow journey back out into the galaxy? Every observation, every data point collected during this critical time is precious. Scientists will be looking for changes in its chemical signature, its dust production rate, and its overall brightness. Projects like the James Webb Space Telescope might even be able to get an incredibly detailed look at its composition. The goal is to build a complete profile of this object, its size, shape, rotation, and makeup before we lose it forever. And this brings us to the bigger picture. The discovery of 3IATLAS, following Oumuamua and Borisov, confirms that interstellar objects aren't just a one-off fluke. They are likely common, constantly zipping between the stars. With new, more powerful survey telescopes coming online, like the Vera C. Rubin Observatory, we expect to find many more of these visitors in the coming years. We might soon have a whole catalogue of interstellar objects to study. Each one will be a unique piece of a galactic puzzle, telling us about the diversity of planetary systems throughout the Milky Way. Are most systems like ours, or are we the exception? These visitors hold the keys to answering some of the most fundamental questions in astronomy. And so, the story of 3IATLAS is not just about a single, strange comet. It's about the dawn of a new era in astronomy, the era of interstellar exploration from our own backyard. It's a reminder that the universe is a vast, interconnected, and often surprising place. While the headlines may fade, the scientific data gathered from this encounter will be studied for years, possibly decades, to come. It will fuel new theories, inspire new research, and educate the next generation of astronomers. That's the real, exciting truth behind this strange tale of 3IATLAS. It's a story of discovery, of scientific detective work, and of our unyielding curiosity to understand our place in the cosmos. Thank you so much for joining us on this deep dive. I hope this has cleared up some of the mystery and given you a greater appreciation for this incredible celestial event. If you enjoyed this video and want to stay updated on the latest news from space, please hit that like button and consider subscribing to our channel and turning on notifications. We'd love to have you as part of our community. Until next time, keep looking up.